Lab 3, Magnetic Field of a Bar Magnet. Introduction. The purpose of this lab was to create a model of a magnetic field visually and observe the effect of distance on the magnitude of the magnetic field. The experiment observed a magnetic dipole moment of 2.32 amperes per meter squared and n equals negative 2.71, assuming the bar magnet acted as a magnetic dipole for the Biot savant law to apply, with initial conditions of a centered magnometer perpendicular to the bar magnet in order to observe the change due to vertical motion. Biot savant law distance dependence equations for a magnetic field. This lab required using the Biot savant law for magnetic fields as well as the distance dependence equations for a magnetic field to demonstrate the effects of a distance on a magnetic field magnitude. System and surrounding. For the observed experiment, the system itself under study is the bar magnet itself, and the surroundings is everything else, with an independent variable of magnetometer position. Experiment. The experiment involved taking a bar magnet with the northern pole oriented towards a magnetometer and then moving that magnetometer to form the initially perfectly perpendicular position in order to measure the change in the magnetic field strength and magnitude due to the different positions of the magnetometer. Data and calculation. Computational model components. I changed the color of all of my vector arrows just in case somebody wants to steal my screenshots. And computational model components, and if you're trying to steal my code, I put a surprise in there. So sources of error. The sources of error include not using a standard magnetometer, but the one that was built into my iPhone, as well as the human errors. I placed my phone by hand to change the distance from the bar magnet. The magnetometer inside of the iPhone isn't perfectly perpendicular to the position of the phone, so I had to actually figure out where that was in order for the experiment to start measuring the effects on the field. And discussion and required observations. The lab ultimately exemplified the Biot savant law, as well as the strength of a magnetic field decreases at the further distance away the observation is. When far away, there's indeed net zero field in the x direction, and it increases in the net x field when moved closer to the magnetometer, but the position does affect the net x magnetic field component. What if and what does it mean? What if you hadn't oriented your experiment to compensate for magnetic north and instead laid your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? There would be some angle theta that the vectors would be off, making it virtually impossible to calculate the components of the magnetic field unless you compensated for the magnetic north, that is. And if you were to stick two identical magnets together end to end and run the experiment again, how would you expect your measurements to differ? They would form a single magnetic dipole, so all the vectors and fields would maintain the same direction, but the magnetic field would have a larger magnitude.